I'm going to go through the solutions to this quiz or test with all the appropriate information. So identify the vertex of the following quadratic polynomial. Remember, this is in the form of a x minus h squared plus k. So this vertex is going to actually be at the opposite of that number there, so -2. And then at the y value of 7. Okay. That's really all you got to do there. Remembering that with transformations that this here is a left or right movement, and this here is an up or down movement, and where our parent function right here is x squared, so we move it left 2 units and then up 7 units, and that's going to put 0, 0, which would have been the vertex of x squared. It's going to put that vertex at -2, 7. Now ask what's the end behavior of p of x. Well, p of x is parabolic. Its a value is +3, so -2, 7 would be maybe there. A is positive, so my parabola is going to be concave up. So as x goes to infinity, as x goes that way, y goes that way, so we go positive infinity. And then as x goes this way, y goes that way, so we would again go to positive infinity. I went with 2 points each on everything here in question 1. It says, how many real x-intercepts does p of x have? Real x-intercepts meaning real numbers that cross the x-axis, and because this does not cross the x-axis, we do not have any real intercepts. Okay, so we would say none or 0 here. But then it says how many complex zeros does it have? If we were to go through and finding the zeros is setting that thing equal to 0, we would see that it doesn't cross the x-axis, and that would be the real zeros. But we still are able to factor that and solve it using quadratic formula, that kind of stuff, and you would get two solutions that have I in them, two imaginary solutions. So this does have 2 complex zeros. So using any method you desire, convert the following quadratic into vertex form. I'm a fan of x equaling the opposite of b over 2a. If I go with 4 over 2, that gives me the x value of my vertex to be at 2. I'm then going to take that 2 and I want to find f evaluated at opposite of b over 2a, which is the same thing as f being evaluated at 2, which becomes 2 squared minus 4 times 2 plus 6. So it gives me 4 minus 8 plus 6, which creates that 2. So that's my y value. Okay, so this was the x value of the vertex. This is the y value of the vertex. So then anything in, remember, any quadratic in vertex form is of the nature, maybe f of x equals a times x minus h squared plus k, where the h is the x value that we've moved left or right. So we have some a quantity, and we'll get to that in a moment, but some a, x minus h, well, that's this value there, so minus 2, squared, plus then the k value, which is your y for your vertex, and that is then the function that we're looking for. And this a now comes into play because we want to make sure that we get the same coefficient that we had out here for this a. That was 1, so I'm not sure why it won't erase, but there we go. F of x has to equal 1 times x minus 2 squared plus 2. Again, that one I made 5 points, I believe. Yeah, 5 points. Just be, no, I'm sorry, that's 3 points. 3 points. Just be cautious. When you find the x and y, you've just found, that point 2, comma 2, that is the vertex. Okay, then how do I take that information and put it back into vertex form? Clean this up a little bit. We'll come down here to part B. It says identify the interval for which the following, or which the function in question 2 is increasing. Okay, well, I guess I should probably have kept the f of x equals x minus 2 squared plus 2. We know that that has a vertex at 2, 2. And this thing has a positive a value, so it's concave up, so it looks something like that. And the values in which it is increasing, that's when the y values are successfully getting bigger and bigger. So from 2 that way, those y values are getting bigger and bigger. So the way we identify the interval is it's the x values. So for what x values are y is it getting bigger and bigger? 2 to infinity. Now I didn't really care whether you put parenthesis around 2 or a square bracket. I would put a parenthesis because at 2 it's not necessarily increasing at 2 itself. It says what is the y-intercept of f of x? Well, y-intercept is simply looking at this form here. It's whenever x value is 0, so I'm left with 6. So 0, 6, and allow you to put 6 and give you points. But remember, y-intercept is a point, an ordered pair. Number 3 says what is the smallest degree of the polynomial that could provide the following graph? So smallest degree of the polynomial, a couple different ways you could do this. You could see that 1, 2, 3, 4, 5 zeros. Okay, so if it has 5 zeros, then we know the number of zeros gives me the number of factors, and the number of factors tells me the leading degree of the polynomial. Okay, another way of doing it is to say if it has 1, 2, 3, 4 turning points. The turning points, remember the formula, we had turning points. Turning points is equal to n minus 1, where n minus 1 is your n being your degree. So if I have turning points, I have 4 turning points equals n minus 1. Add 1 to both sides, I get n to be 5. So there's 2 ways of doing that. Either look at the zeros or look at the turning points. I think it's easier to look at the zeros, but that's your option. 3a says if provided. If provided a graph, no, that's right. If a provided graph has degree 7, list the varying amounts of possible turning points that have the function cat. A couple different ways of doing this. I think drawing a picture is going to be useful. And what I did is I created GeoGebra for us here. Here's a situation where we know that this function is a 7th degree polynomial. If I look at the factors here, I should have 7. 1, 2, 3, 4, 5, 6, 7. And I wish I could expand this for you and show you the multiplication, but the way I wrote this doesn't allow that to happen. But it's a 7th degree polynomial there. And if I look at this right now, and the idea is that those zeros all have a multiplicity of 1. Okay, all those zeros are different. And that gives me then this picture. So I have 1, let's just, maybe I can find the extremums here of this curve. And those red points then are your turning points. So you got 1, 2, 3, 4, 5, 6. So we have the possibility of having 6 turning points there. But what happens when some of these points become the same thing? So let's say that G becomes F. Okay, sorry. I just kind of repositioned things here. But let's say that G, so at the current stage we have 1, 2, 3, 4, 5. Let's scroll down here a little bit. We get the 6th turning point there. But in the event that G becomes F, so we have that situation, okay? We still have the same end behavior. We still have over here, still have 7 factors, but you see that 2 of those factors, the x minus 10, x minus 10, are in fact the same thing. So you got a multiplicity there. Well, if that happens, then how many turning points are you left with? 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so still got 6 turning points there. But what if we do this? What if we create that? Now how many turning points do you have? Well, 1, 2, 3, and now 4. Okay, and that's just because, again, we now have a odd multiplicity here. Okay, with the x minus 8s. So we had 6, we saw 6 again, now we see 4, and now let's create, these points to all be the same. Okay, and now again, you still get, I'm zoomed out real far here, but you could still get that value right there to be a turning point. Let's see if we can zoom in on that. J. It's still, you see that it is still a turning point, still a maximum there. It's just a very shallow one. So we still get 4 turning points, but now let's maybe move these 2 together. Okay, and we move those 2 together, we still get 1, 2, 3, 4 turning points. Okay, so 6 and 4 so far, but now move those points all together. Now again, we're zoomed out real far, so let's zoom in. Zooming in, that gives us that H to be a turning point, and we'll get the same thing over here for that point there to be a turning point. And let me actually go back to the standard view. I think you can see those turning points a little bit better there. That's the standard view. We were zoomed out pretty far on the Y direction, but you see now that we've got this point here is actually what we refer to as a kind of an inflection point. You got 2 turning points, the top one there and that one there. But what happens now when all of these points coincide? They all become the same point. Maybe there. Now you get 0 turning points. Okay. So what happens is basically we get 6, 4, 2, or 0. I wanted to show you the picture. I don't know if we've done that in class. We've talked about it. Maybe drew it by hand, but not really using GeoGebra. Whenever you have turning points, the first, or the largest amount of turning points you could have is always n minus 1. So n being 7. So we get 7 minus 1 gives me 6. And then we can differ by amounts of 2. So 4, 2, or 0. If I gave you like an 8, you can go 8 minus 1 would be 7. And then you can go 5, 3, or 1. So that's the setup for that question. If we go to this one, just says circle the graphs of those are polynomials. This one's a polynomial here. This one's a cusp. Okay, so that's not a smooth curve, so that's not a polynomial. This one has a break in it, not a polynomial. That's a piecewise. This is probably a piecewise as well. Here it says complete the end behavior. All right, so I've got a 4th degree polynomial, but the A value is negative. So any 4th degree polynomial where A is negative is going to maybe look something like that. Depending, just like we've talked about in class, we don't necessarily know what's going to be happening here on the interior, okay? But we do know that as x, maybe my x-axis and y-axis are kind of over here. As x goes this way, to negative infinity, y is going to negative infinity. And as x goes that way, in positive direction, then y is going to negative infinity as well. So these two both have to be negative infinity. Okay. Um, and you can, take any values of A, take any values of B that you want to. Maybe we do that in GeoGebra real quick, give you a better maybe view of that. I think I had negative AX to the fourth plus BX cubed plus 3. Okay, and no matter what A is, positive, negative, whatever, you see that end behavior. I guess sorry, not positive or negative. If I make it negative, you see how a minus a negative becomes a positive. So I want to keep my A value just with this slider over here, so it maintains the idea that my coefficient is negative. But as I move that end behavior is still decreasing this way, still going to negative infinity this way as x gets bigger, and it's going to negative infinity this way as x gets bigger than the negative direction. The B value, it doesn't really change that end behavior. Okay, so that's that one. The next one was, I believe I gave you a cubic, so well, actually it looks initially like a cubic, okay, because we got the bx cubed, and if you looked at it this way, you probably would have gotten the right answer. But I'm actually looking at, remember it's got to be in descending order. Dx to the 7th is the one that we're interested in. And anything dx to the 7th, maybe minus cx to the 4th plus bx cubed, doesn't really matter what the cx to the 4th and the bx to the cubed are doing. That's what's important. And anything that's a 7th degree polynomial is going to look something like that in behavior. Obviously doing weird things maybe in the middle, but as x goes to positive infinity, so does that. As y goes to, or sorry, x goes to negative infinity, y goes to negative infinity. So that's what we're looking for those two in behavior questions. All right, now with this one we want to divide the polynomials. If you used synthetic division as k, I suggest long division here. Put x minus 3 out front. Underneath that, we're going to go with 3x squared minus 10x minus 4. I'm going to put 3x right here because that's what I need to multiply by x to get 3x squared. So you get 3x squared. And it becomes minus 9x. And here's where everybody made their mistakes if they missed this. I want to multiply everything by negative 1. And then I want to add straight down. So when doing that, I'm going to get those to cancel out. I get negative x minus 4. I was getting a lot of people to have like 19x here. I then need to multiply by a negative 1 to get this to be negative x, then plus 3. Again, I'll go through and multiply that by negative 1. Changes that sign, straight down gives you negative 7. And now I stop because that negative 7 is of a lesser degree than that x to the first. So that's my remainder. So this is r of x, this is d of x, and this is q of x. And what I was trying to get you guys to do is rewrite this as your quotient, 3x minus 1, plus then your remainder of negative 7 over your divisor of x minus 3. This next one says determine the polynomial of least possible degree that will create the following graph. Says no need to expand the polynomial. Make sure we're paying attention to the directions. A lot of people did this, wasted a lot of time. We get a 0 here of negative 2, so it's going to be a factor of x plus 2. There's a 0 here of negative 1, so it's going to be x plus 1. There's a double root here of x of a 0 of 1. So I'm going to write that as x minus 1 squared. Now, the only thing that you have to pay attention to here is that there is some a coefficient out here, which is p of x equals that. But the key thing to notice is that we have a critical point on here. We have a y-intercept of what looks like, maybe not the y-intercept. Let's not look at the y-intercept. Let's look at the Yeah, that's y-intercept's fine. The y-intercept here is 0, 2. I had to look at the paper to zoom in on this to see that we do know that to be exactly 0, 2. But you could use this point here as well. You can use a couple other points if you want to. It doesn't matter. But we know that the point exists, so I want to try to find this a. So if x is 0, so I would get 2 there, 1 there, -1 there, squared, which is +1. Multiply all those things together, you get a y value of 2 to equal 2a. So a is 1. So whether you did that or not, that's okay, but you get your a to be 1. So this is all we need here for that polynomial. Key thing was to say least degree, because as long as that's an even multiplicity, the graph's going to still look the same. So if that was a 4, it would still look something like this, but it would be a 6th degree polynomial instead of a 4th degree, and so forth. With this one, I was asking for all the possible roots for the polynomial, and when I ask it that way, we're just looking for all the potential p over q's. So remember, p is the factors of your constant term, so plus or minus 1, plus or minus 3, and q are the factors of your leading coefficient, your leading term's coefficient, so plus or minus 1, plus or minus 2. Write them as then plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 3 over 1, and plus or minus 3 over 2. That's all I was looking for there. Some people went further and started finding the zeros. That's kind of what these next couple questions are doing for us. So it's provided that -1/2 and 3 are two rational zeros of the above polynomial, show the necessary work to find the remaining zeros. A lot of you did this different ways, but somehow if you kind of go through and show me with either synthetic division or long division that you start to get other zeros to show up, would be fine. So this is the way I would do it. If I know 3 is a 0, I'm going to put 3 there, put my 2 down, 6 gives me -3, this gives me -9, gives me 0, 0, 1, +3 there, +3, and that gives me a 0. So I knew that was going to happen because it was told that 3 was a 0. But I also know that -1/2 is a 0, so I'm going to do that. Put -1/2 there. Bring my 2 down. Multiply 2 by -1/2 gives me -1. Add those, it gives me -4. 2 there. Bring that 2 down. Multiply gives me -1. There's a 0. So now, remember, this was x to the 4th. This would have been now x cubed. And this is x squared. Okay. So now I know 2x squared minus 4x plus 2 is going to provide other zeros. So I'll make that equal 0. I'm going to factor a 2 out. So it gives me x squared minus 2x plus 1 equals 0. And then that gives me x minus 1 equals 0. And there are your two additional factors that create zeros at x equals 1 and x equals 1. Those are your two zeros. The next thing was to take the information out of question number 9 and rewrite all that stuff as just a kind of factored polynomial. So we have the 0 that, I'll just kind of do this over here on the side. We had the 0 here that -1/2 and 3 were zeros. So P of x. So P of x has a 0 at -1/2, so as a factor of x plus a half. We had a 0 at 3, so it gives me x minus 3. And we had a 0 at 1, so it becomes x minus 1 quantity squared. But now if you think about this, you multiply all that stuff out, you're going to get x to the 4th. We want 2x to the 4th. So we need to put that multiplier out front and get p of x is equal to 2 x plus a half, x minus 3, x minus 1 squared. You don't have to multiply that out. You can if you want to. A lot of people will maybe put that 2 through one of these factors. That's fine. That's what we're looking for. If you, I guess you don't want you to multiply out the direction, say fully factored form. If you multiply it back out, you should get that, though. That'll tell you you've done it correctly. Right now, this last one says, I said to take this last one and rewrite this as 2 plus I. The idea is that A plus BI and A minus BI are conjugates. If I write it as BI plus A and BI minus A, those are not considered complex conjugates. So we have to write it as 2 plus I. But what it tells us is that we have a complex 0 of 0. Okay, so that means x minus 0 is a factor. We have 2 plus I as a 0, so we got x minus quantity 2 plus I. So we have the 0 here of x minus 0. We have the 0 of x minus 2 plus I, that thing there. And then we have x minus its conjugate. Remember the complex conjugate's theorem. It says if 2 plus I shows up, its conjugate has to show up as a 0 as well. Making that a little bit easier, x minus 0 obviously is just x, so that's not really needed. Now I look at this thing, I want to multiply this out. I think a lot of you are probably comfortable with doing this. Rewriting that first factor as this, writing the second factor, just distributing the negatives through like that, and now you got trinomial times a trinomial, so go ahead then and FOIL that out. So just FOIL this out, take all three of these things, multiply by all three of these things. Now you're going to get some things to cancel out here, combine like terms, that kind of stuff. So I'm going to get, your positive xi and your negative xi drop out, negative 2i, positive 2i drop out. This negative I squared becomes a minus a negative 1, so plus 1. So now combining those stuff, we've got the x out front, which is still that x there, which was the 0, I guess it was down here, it was this 0 right there. We're going to have x squared then, minus then 4x, and then we got the positive 4 plus this one here, gives me 5. So now I'm multiplying this x through, should give me x cubed minus 4x squared plus 5x. And there is the expanded version of that polynomial. Okay, x squared minus 4x squared plus 5x. That's that. That's the entire test. I'm going to go real quick through and give you the point values for all these. I started doing it at the beginning, but kind of stopped doing that. Before I do that, I just want to apologize. My daughter crying in the background. So let's go through and write down these point values. Let's see here. Question 1, total was worth 10 points total. Each part was worth 2. So we went 2 there, 2 there, 2 and 2. And I guess it was, this one was with 4. It was 2 points there and 2 points there. Number 2, I believe this was, I went 3 points there, 2 points, 2 points. Down here, question 3, this was 2 points, 3 points. When we get to question 4 then, question 4, part I guess creating or circling the right one, that was only 2 points there. And then each one of these was 2 points. So 2, 2, 2. Question 6 then on the second page, this would have been, I let this be 6 points. Question 7 was 8 points. Keep moving through. Question 8 was also 8. So question 8 was 8 points. 7, like I said, was 8 points. 9 is 8 points. 9A was 8 points. And 10 was 8 points. If you count those up, I believe that's a total of 80 points. Overall, I think we did pretty well on this. Class average was low 80%. There is a strong direct correlation to those of us that are doing the homework on a consistent basis, asking questions on a consistent basis, and doing well on tests compared to those people that aren't doing the homework on a consistent basis, aren't consistently asking questions. So please, if you're a person that is struggling right now, please know that there are benefits to asking questions and creating discussion, and obviously putting the time and effort into homework. It pays off in the long run.